this is a recording of the notes for 4.3 examples, starting with the fact that we have gone through example 2C. I have that on the slide right now. If you have not gone through this part of the notes, then you want to go back maybe to my YOLA site and copy down things up to and including example 2. Now, the next thing that we're going to talk about is something called a reference angle. And on this slide, I don't want you to write anything down because we'll write something on the next slide, except we might write the definition of a reference angle. If you remember, and I'll just squeeze in a little quadrant 1 angle, if our angle is in quadrant 1, that means theta might be in that position right there. And we can find all 6 trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. And everything is positive. We talked about having a point on that terminal side and kind of thinking about that little right triangle. I'll use a bunch of different colors so we can kind of see. Having a little right triangle, there's my angle theta. This along here is x. This along there is y. We talked about the fact that that's r, which is the square root of x squared plus y squared. And so that's all fine if everything's in the first quadrant because everything is positive. Then when we get to the other quadrants like quadrant 2, quadrant 3, and quadrant 4, we want to be able to handle those angles. Well, lucky for us, there is something called a reference angle. And so if I'm in quadrant 2 that I'm kind of highlighting right now, and this is my angle, its reference angle is going to be the angle made with the now negative x-axis and up to that terminal side. And the book authors call that theta and theta prime. I often refer to that just as the reference angle. So in this situation, our reference angle is this angle right here. I want you to make a mental note right now that the reference angle is always going to be made with the x-axis and then either up or down from there. We never use the y-axis when we're trying to find a reference angle. So then I'll go over, and here's quadrant 3, and you're just looking at this because you're going to write it on the next slide, I think. And then for quadrant 3, I maybe have this as my angle that I'm highlighting right now. And so then my reference angle, again, is going to use the negative x-axis along with the terminal side, and that angle is going to be right there. So that is the reference angle that we're kind of thinking about in this situation, and this was the reference angle in that situation. So then likewise, if we're in quadrant 4, then our original angle has an initial side on the positive x-axis, and it goes all the way around to here. And I see they didn't quite mark that on this slide, so it goes all the way to here. And there's our terminal side. Then this reference angle is going to go from this time the positive x-axis and to that terminal side, kind of the closest way that we can go. And for right now, don't worry about any of that stuff. I have a method for you to remember that. I just want you to get visually the idea of a reference angle, and always using the positive or negative x-axis. So here the positive x-axis, negative x-axis, negative x-axis, and the terminal side, and kind of using the shortest distance between those two things so that you can find where those are as you look. From this information, you could write the definition of a reference angle. So the reference angle is sometimes called theta prime, and man, I don't even know if you want to write that down. The reference angle is just called theta prime, and I think we'll look at the next slide to say what we're going to say for this. Now, if you want to, oops. take a moment and write down the reference angle rules. I'll leave this one here, or you can pause this if you need to. I will read it to you. If theta is an angle in standard position, its reference angle, theta prime, is the acute angle formed by the terminal side of theta and the x-axis. The reference angle, theta prime, for any angle theta, 0 less than theta, which is less than 360, or 0 less than theta, which is less than 2 pi, is determined as follows. And you might want to just take a minute and now draw a really nice piece of notes for yourself showing you personally where that reference theta angle is. And again, I'll just say a little bit about it. If it's in quadrant 1, the actual angle and the reference angle are exactly the same. I'll kind of trace them in these two colors. And if it's in quadrant 2, the actual angle is right there, and then the reference angle is right there. If it's in quadrant 3, our original angle is right there, actual angle, and our reference angle is right here. And if we're in quadrant 4, our initial and terminal sides are here, kind of going all the way around, and then our reference angle is also here. Just a note on this last one, the reference angle is just given as a positive value as you're kind of thinking that through. If you need to pause this to write that slide, go ahead, and then I will be moving on. Okay, so now hopefully you've written that. Pause this and back up if you need to still. And now we're going to look at sketching some angles and then finding their corresponding reference angles. So the first one, 3A, is negative 150 degrees. And so our job is first to sketch the angle and then find its reference angle. So I'll just draw a coordinate axis here. It's a negative 150 degrees. My initial side is on the positive x-axis. Since it's negative, I'm going to go clockwise, and I'm going to pass 90, but I'm not going to pass 180. So it's going to be someplace out here. And I'll just kind of do that. So this is my negative 150 degree angle. And then when I find my reference angle for this one, my reference angle, and again, sometimes I call it the reference angle. I'll try to call it theta prime right now. And that angle is the angle that goes from the x-axis, which in this case is the negative x-axis, and then down to that terminal side. And so for this one, the way that I do that is I say, well, if that's negative 150, if I'd have gone all the way, it would have been negative 180. So I just take 180 minus 150 as I go through that. So our reference angle is 180 minus 150. And so then our reference angle is 30 degrees. And you're going to find that that's an important thing to be able to get. So our reference angle is 30 degrees for that one. Then our next one is in terms of pi, and so this is 3b. It's 3 pi over 4, and I'll draw my coordinate axis again. And this time I'll draw my angle at 3 pi over 4. So initial side is positive x-axis. I'm now going counterclockwise since it's positive. I'm at 0, if I want to kind of count in force, this is 2 pi over 4. This is 4 pi over 4, and I'm past 3 pi over 4. So if that's 2 pi and 4 pi, it's going to be out here someplace. So there's my angle that I'm starting with. 3 pi over 4 is theta. Then, if you'll notice, I wrote this as 4 pi over 4. And so that's going to help me because my reference angle uses that negative x-axis and that terminal side again. And so this is the angle that I'm looking for as theta prime. And so my reference angle or theta prime. For this one, I'm going to say, okay, well, if from 0, and I'll write in yellow and then get rid of it, 0 to here is 4 pi over 4, and 0 to here is 3 pi over 4. This is the difference between those two, and I didn't really say that in the last one, maybe I should have. And so to get that reference angle, I'm taking 4 pi over 4 minus 3 pi over 4. So my theta prime, my theta prime is equal to pi over 4, 1 pi over 4. And it's illustrated there as well. So that's the concept of finding a reference angle. Once we can find a reference angle, you'll notice that, remember the table that I asked you to be able to generate, and both pi over 4 we'll be putting on that table, but in the previous one, a 30-degree angle is on that table. And now we're going to talk about finding trig functions that are not in that first quadrant, using the concept of a reference angle, that table that we can generate, and another relationship about the sine. And I'll go over that in just a moment here. So the next thing you're going to look at is the directions, this key concept for evaluating trigonometric functions of any angle. And it's a 3-step process. The first thing you do is you find the reference angle, theta. The second thing you do is find the value of that trigonometric function of theta prime, so that reference angle. And then using step 3 is using the quadrant in which the terminal side is, determine the sign, S-I-G-N, positive or negative. So positive or negative sign of that trig function. So I'll give you a moment to write that down, or you might want to pause this. I will just wait a moment. Okay, so now on this same slide, I'm going to write some really super important stuff that I want you to just know very well. First, I'm going to generate that table that we have already practiced generating. And I think probably this week, if you're in class a few days, I will be going over kind of reminding you about generating that table. And we'll kind of look at that later in the week as well. So now I'm going to kind of slowly generate the table. We haven't generated it for a while. I'm going to put an extra row at the top. So I'm going to start here by using my angle theta right here. And then I'm going to put a row way up above the top. And then, as you know, we use sine, cosine, and tangent. And if you've forgotten how to generate that table, I'll just kind of do a little reminder of that. We'll put in our theta values first. Our angles are 0, 30, 45, 60, and 90. If we were all here together, I would have you generate that, but I just want to kind of give that information to you. And then I'm going to remind you how we find these different values. Sine, we start counting from the square root of a number over 2. And we progressively count from 0 up to 4. And so that's how we get our 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And then for cosine, we just start at 90 and go back and do the same thing. 0 in reverse. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And notice the square root of 2 over 2's are together. And then the tangent is sine over cosine. So those are 0, square root of 3 over 3 when we rationalize that denominator, 1, square root of 3, and our last one is undefined. Now, the new line that I want to ask you to do is put theta in radians. And I'm just going to ask you to kind of think that through. I'm going to erase this stuff that I'm writing over on this right side in just a minute. But I'm going to ask you to notice that if we convert those, and I'll just do one of them, well, obviously 0 is also 0 in radians. But if I take 30 times pi over 180, notice that 30 goes into 180 6 times. And so 30 degrees is pi over 6. And then likewise, 60 degrees is pi over 3. So those are kind of easy for me to remember by keeping that in mind. And then for 45, if you aren't sure right now, 45 goes into 184 times. So that's pi over 4. And then we've talked enough about 90 degrees that that's pi over 2. So this is now the full table that we want to be able to generate. And if we can generate that table and then use what I'm going to tell you next about the positive or negative sign and finding that reference angle, then we can find the exact trig function value of many things. So the next thing I'm going to show you is a way to figure out the signs. And I think I talked about this last Thursday, the last time that I was here. We're going to use a mnemonic device right now. And that is that all students take calculus. And we're abbreviating that on the quadrants as all students take calculus. And I'll write the little phrase here, all students take calculus. And then I can only hope that that'll be a self-fulfilling prophecy for you, but if it's not, that's okay too. But this is what we're going to say all the time. Remember, all students take calculus. So the A for all means all trig functions are positive. All trig functions are positive. The students has an S, so it stands for sine. So sine is positive, and its reciprocal is positive. Positive. Sorry for my sounding out. And then the take, or T, means that the tangent function is positive. So when I say the tangent is positive, then that means the sine is negative and the cosine is negative. And that should make sense then, because sine divided by cosine is tangent, so a negative divided by a negative is a positive. And then C, you've probably already guessed, means that the cosine function is positive. I'm not saying anything right now about cotangent, secant, or cosecant. They follow their reciprocal functions as we go. So the mnemonic device is all students take calculus, and it helps us decide in what quadrants things are positive and negative. The book authors give us this information just written a little bit differently as we look at it. And I'm going to pause a minute for myself, but you will probably just hear me. Okay, so what I did while I paused the video is I just copied some of this so that I can paste it on some of our slides as I talk you through this. And I also just put, this is what I'll be putting on some of our problems so that it's easier to follow along. Our book authors give, this is the slide that tells what our book authors give. I'm actually, I have on here already that it says, ask me about all students take calculus. I've already covered that with you, and ask me about generating a better table. And so I'm just going to say that, I've gone over that. This is the book author's version. I think my version is just a little more expanded than that. So here's our problem number 4. Find the exact value of the sine of 4 pi over 3. So I'm going to paste my information on here just so that I can see it, and you probably should have that in front of you right now as well. And then I'm going to go through that same process, that 3-step process. And since we're not real familiar with this for 4a, I'm going to graph that just like we did in the previous problem. I want the sine of 4 pi over 3. So in these, I'm going to sketch my original angle. So my initial side is right there at the positive x-axis, and I'm counting by pi over 3. So this is 0. This is like 1.5 pi over 3, so pi over 2. This is 3 pi over 3. This is 4.5 pi over 3. Not really the way I would ordinarily write it, but it gets me through this little part. And then 6 pi over 3, which is equivalent to 2 pi. So when I plot this one, 4 pi over 3 must be in that third quadrant. And so I'll put it kind of in there. So this is my original angle, theta. And then I'm going to find my reference angle. Just a reminder, I have to use that x-axis, positive or negative, doesn't matter, and I use that little chunk right there. So since this is 4 pi over 3, I'll rewrite that in green, or excuse me, 4 pi over 3. Yep. Since that is 4 pi over 3, to find my reference angle, I'm going to take 4 pi over 3 minus 3 pi over 3, which is that 1 pi. And I'm going to get my reference angle as equal to pi over 3. And so then just a reminder, pi over 3 is 60 degrees, and I'm gonna slide this over a little bit. I put it here, but I want it out of my way. And you have this generated so you can see it a little bit better. So now I'm gonna look at my chart. I have my reference angle of pi over 3, and so I'm looking at this column right here. It says I'm looking at the sine, so here's the sine of pi over 3, square root of 3 over 2, and then I have to decide if it's positive or negative. And so right on my original table, I'm going to also write this, all students take calculus. So that means tangent is positive, and since I'm finding the sine is negative. Sine, S-I-N-E, sine is negative. And so when I'm finding the sine, now I'll write my answer. The sine of 4 pi over 3 is equal to the negative sine of pi over 3. And so that is the negative square root of 3 over 2. And so that is my answer to this problem, negative square root of 3 over 2. And here's my book author picture and book author answer. I'll just kind of slide that up here so we can see their version of that. So that's what we do. Just to recap, and I'll write in yellow a second, then I'll get rid of it. Just to recap, I drew the picture. I found that reference angle here that I needed by going to that positive or negative x-axis and the terminal side. I use my table to decide what my fraction is because it's going to be an exact value. And then I use this all students take calculus to decide if my answer is positive or negative. So that's what we're going to be working through in these problems. Now I'm going to go just a little faster on this next one just to kind of see what we're doing. So this is again exact values that we're finding. So 4B is find the exact value of the tangent of 150 degrees. And so for this one, I'm going to draw my picture. Again, my angle 150 degrees is someplace between 90 and 180, so there's my actual angle. My reference angle is going to be to the 180, so my reference angle is equal to 180 minus 150, so my reference angle is 30 degrees. I write in my all students take calculus. It's in this S quadrant, so that means sine is positive, and so that means tangent is negative. So then I'm going to write my problem. The tangent of 150 degrees is equal to the negative tangent of 30 degrees. And then let me see if I can kind of paste my table on here and see if that's what I'm still pasting. Yep, I can paste my table on here, and then the tangent of 30 degrees, I can just look at that table, and the tangent of 30 degrees is the square root of 3 over 3. So we should be getting kind of good at that table, I don't know. Negative square root of 3 over 3 for that one. And here's our work from the book authors. So that's what we're doing for finding different values. The next thing I'd like to go over, and I do want to take a little bit of time to go over this, and then that'll be the end for today. I want to do problem number 5, just so that you can see it, and then we'll be moving on. Maybe I can get 6 in, I'll see. Then problem 4C, oh, I forgot that there was another one, asks us to find the secant of 15 pi over 4. Now notice 15 pi over 4 has had a couple of rotations as we go along. So same thing, I'm going to start with this. I'm going to think about these in force now. 0, 2 pi over 4, 4 pi over 4. 6 pi over 4, 8 pi over 4, 10 pi over 4 here, 12 pi over 4, 14 pi over 4, and 16 pi over 4, kind of to go the revolutions there. So 0 to 2 pi, and then to 15 pi over 4 would be right there. So our reference angle is just from there to there. So I'm going to actually, since I already have it written this way, take just 16 pi over 4 minus 15 pi over 4. But I can repetitively subtract 2 pi and get that as well. So the reference angle is pi over 4. And then my all students take calculus. That means in this quadrant cosine is positive. Remember that secant is 1 over cosine. So cosine is positive and secant will be positive, is positive. Now, the way I'm going to find my answer now, let me paste on that table again so that we just have that information handy. And I'm going to work right here now, and I'm going to say, okay, this is the secant of 15 pi over 4, which is equal to 1 over the cosine of 15 pi over 4. And that, using my reference angle of pi over 4 and the fact that cosine is positive and so is secant, this is the same as 1 over the cosine of pi over 4, using that reference angle kind of right there, that piece of reference angle. And now cosine of pi over 4 is right here, square root of 2 over 2. And so this one, and now we have to kind of invert and multiply 1 over square root of 2 over 2. And so then that's going to be 1 times 2 over the square root of 2. And that was my equal sign in between there. I'm going to just rewrite that a little bit because I don't want it to be confusing. That was equal to 1 times, and I'm inverting and multiplying. And then for this one, I'm going to rationalize the denominator. And so I'm going to get on the top 2 the square root of 2. On the bottom, square root of 2 times square root of 2 is plain old 2. Then those cancel, and this is the square root of 2. So I get that the secant of 15 pi over 4 is equal to this positive square root of 2. And positive because of what quadrant that ended up to be in. Now, I will just do this one more problem, number 5. And for number 5, it says use one trig value to find others. And in this one, we're going to use the fact that this is in a particular quadrant to help us decide. And we'll draw a right triangle as well. So number 5, we know that the secant of theta is the square root of 29 over 5. And we know that the sine is greater than 0. Well, just keep in mind that secant is equal to 1 over cosine. And so since secant is 1 over cosine, that means cosine is also positive here, and sine is positive. So when we decide what quadrant that is, all students take calculus. Since we knew that, in just a second, I'm going to move something. Since we know that the sine is positive, then it can only be in one of those two quadrants. And then, like I just said, since the secant is also positive, then we can, let me get that out of the way a minute. Since the secant is positive, that means that cosine theta is 1 over secant theta, or secant theta is 1 over cosine. So that means that the cosine is also positive. And since cosine is positive, it can't be in that quadrant. So we've identified that it must be in quadrant 1. And that won't always be the case, but in this one it is. So all of our trig functions are going to be positive. So that makes this problem a little bit easier. The next thing we're going to do is we're going to say, okay, I'm going to just draw a right triangle. So I should write, though, that theta is in quadrant 1. And so all trig values are positive. So now I'm going to just draw a right triangle, and I'm going to put theta in this corner. And then I'm going to say, okay, if the secant of theta is the square root of 29 over 5, remember, secant is 1 over cosine again. And so since cosine theta would be adjacent over hypotenuse, I can say that secant is the hypotenuse over the adjacent side. So then when I look at this picture, that means my hypotenuse is the square root of 29, and my adjacent side is 5. Then I can use the Pythagorean theorem to find this missing side over here, and then I can just simply write all my trig functions. So since that is the hypotenuse right there, and this is the other side that I know, when I do this problem, I'm going to say this is the square root of, oops, I do want to use a different color right now, sorry. I'm going to say this is the square root of 29 squared minus 5 squared. So it's the square root of 29 minus 25. It's the square root of 4, so that side is 2. And now since I identified all my signs, in a different problem I might have to figure out which trig functions are positive or negative, but now I can just write all of my answers. The sine of theta is opposite over hypotenuse, so 2 over the square root of 29, which we know is 2 the square root of 29 over 29. The cosine of theta is adjacent over hypotenuse, so 5 over the square root of 29, or kind of the reciprocal of the original. And so that's 5 the square root of 29 over 29. The tangent of theta is opposite over adjacent, so that is 2 over 5. Cotangent theta is 5 over 2. Secant theta we were already given, which is the square root of 29 over 5. And cosecant theta, remember we want to pick that from this original right there. So I'm going to get rid of those little dots I just made. But cosecant theta is the square root of 29 over 2. So that is a long lot of lesson, and I just want you to get through that, and then we'll go over some more again on Wednesday will be our next new piece of lesson.